Okay alle sammen, vi prøver en gang til. Vi beklager de her tekniske problemer, men det er som sagt først anden gang, at vi laver et webinar. Og nu vil jeg gøre introduktionen meget mere kort. Altså det er det andet webinar, vi holder, og vi håber, at det her det bliver en succes på længere sigt. Vi har inviteret en god ven af Danmarks Biavlerforening, Sjef Steen fra Holland af, fra Wageningen, som har været i Danmark flere gange på besøg, og i øjeblikket så arbejder vi sammen med ham omkring noget varroa. Og Sjef han vil i dag fortælle noget om the honeybee colony as a biosampler for pollen, pollutants and plant pathogens. And we will leave the scene for you now, Sjef, and we hope that the sound will be better this time.
I hope so. Thank you, Prem. Thank you, Fleming. I thank you all for watching, and it really is a big honor for me to be here and to present a webinar. It's the first time for me. I do a webinar. I'm quite excited about it. And I'm sorry that I have to do it in English. I tried some words in Danish, but even then you couldn't understand. And the only word I really can pronounce very well is tak. And so I say tak to you for listening. And now we start with the, the presentation about the honeybee colony as biosampler of heavy metals, pathogens, pollutants and pollen. And you see it's quite a different approach of the honeybee colony. We're all beekeepers. We have our bees to collect pollen, to collect honey, nectar, to make honey of it and water. But along with collecting all this stuff, they take everything that's in the flower along. And that's how we can use the honeybee colony as a biosampler. But before going into the studies I did on this subject, I would like to introduce you some familiar things about the honeybee colony that are really important for the application of the honeybee colony as a biosampler. So let's start. Our forager bees collect nectar. They collect pollen, and by doing so, they do it inside. This one. No. They do it inside the flower, and doing this, a lot of pollen is collected on their body. But along with the pollen, they also collect dust and plant pathogens, etc. So the forager are the collectors, and the colony is really the real sampler, because we have a lot of foragers, and we try to subsample the colonies and to see what they have found. So after they have collected the stuff in the flowers, they go back, and then we can use the honeybee colony as a sampling tool. And that has a lot of benefits, because you don't have electricity, and there are honeybee colonies all over the world, and you can use them all over the world, even in places where there is no environmental infrastructure, whatever. So let's try what we have done here. Looking to the honeybee colony as we have them here in the northern of Europe, we have about 30 to 40,000 bees in our colony. That means that we have a lot of employees that are working for us for free. The slide I show you is just for your indication how many bees there are in the colony, and normally we work, at least in the Netherlands, with 20 frames colonies having about 30 to 35,000 bees. But not all bees are forager bees. Several years ago I did some studies about what is the distribution of the age, because we all know that all the bees are the forager bees. How many forager bees are in the colony? I checked them by coloring bees, checking them where they were and on the location in the beehive, and I found out that they were quite well distributed all along the colony, and that indeed 25% of the bees are forager bees, have the age of being forager bees. That are our employees, and they're collecting honey, and they're collecting pollen, and just starting with honey, they collect about over 100 kilogram nectar per year. And doing this, they're making 3 million flights. You can imagine that they collect a lot of stuff along with nectar. They can fly up to 3 kilometers, but normally they do it within 1.5 kilometers. For pollen, it's more or less the same. They don't collect 100 kilograms of pollen. They collect about 30 kilograms, having over 1 million flights per colony per year, and collect the pollen in an amount about 10 to 30 milligrams. As well as they collect water up to 25 kilograms, but we all know that part of the water is also coming from evaporation of the nectar, turning into honey. It's about collect, and as you have seen about the amounts that the bees were collecting, you can see that the nectar forages, as we can see here, I put the point on here. As you can see here, there are much more nectar forages as we have water or pollen forages. So the nectar forages are really important when we use the honeybee colony as a biosampler for the pollutants and the plant pathogens. Focusing on the forager bee, we already said we have a foraging distance about 1 kilometer. They can fly about 800 kilometers, and they have a task constantly. That means that flowers collect whether pollen or nectar, and about 20% are collected in both, because there's nothing in nature that's absolute, so it's the same for the task constancy. And this is an interesting point. If you have a very good location where the bees collect the pollen and nectar, they have different behavior inside the flower. And it also has an impact on the amount of nectar and pollen that can be collected. On good flowers, bees turn around and leave in another direction as they have come. It's very nice to see and observe in the field. Every bee flies, forager bee flies about 10 times a day, and they have also this flower constancy, not only task constancy, flower constancy, and again, this is not 100%. They communicate. We all know the famous bee dances that we have, and by doing these dances, they recruit foragers to follow them, and that's how the honeybee colony can focus on certain crops, and they are really mouse foragers. So on certain crops, they have a lot of bees coming there, indicated by them by the dances. That's the time about 100 years ago discovered by von Vries. This is an interesting slide, at least I think it's an interesting slide, because using this honeybee colony as a biosampler in an apiary, not all the honeybee colonies inside in the apiary are foraging on the same area. They are distributing themselves over an area. The exact mechanism, how it works, we don't know. But when you want to have a picture of an area to see what bees can collect, you need more than one colony. This was at the time made, you see it's a long time ago, by Mr. Waddington. And you see on these slides, and I can show you, for instance, here, these bees are foraging more or less around in the colony one, around the hive. This as well. Going to another day, here, colony one is going more to the south, to down. Colony two has another foraging pattern. This goes along these days, and at the end of this observation, of this study, you see that most bees of colony one are going down, and colony two, they are going in the center. They're foraging in the center. So they have different places where they sample their stuff. Now, this about honeybee colony. Now back to the pollutants and plant pathogens. They don't collect them intentionally. They do it unintentionally. They do it along with this collection, as I said, with water, honeydew, pollen, and propolis, and that's why we call it the passive load of the honeybee. What exactly is a passive load? Well, we all know that when bees collect pollen, but also when they collect nectar, they get a lot of stuff in the hair and they clean themselves. Even the pollen collects clean themselves much better than the honeybee colonies that are collecting nectar. They can't collect. They can't clean themselves completely. Part of it, about 2 to 3%, stays in the hair, and they can't remove it. And this what is left on the bee's hair we can use to see where the bees have foraged on, and to see if they have collected pollutants or other plant pathogens. Every bee that leaves a colony has up to 7,000 to 10,000 pollen grains in the hair. It's normal. I can show you a slide later. So every bee has a certain amount of pollen and pollutants in his hair leaving the colony. Okay, we were talking about the honeybee colony, but you don't sample a honeybee colony. You sample bees. And where do you sample bees? You can sample inside the hive or at the hive entrance. But when you sample at the hive entrance, you have a lot of bees. You have guard bees, you know that. You have bees that do it for the ventilation, orientating bees, bees that entering from the foraging flight, from the pollen flight, from the water flight, and also the hive leaving bees. When you want to sample inside the colony, you have to know where to be. And as I showed you before, the age cohorts are more or less distributed equally over the frames. So when you take an inside hive sample, you have not only foragers, you also have other bees, younger bees. This slide shows you that bees that are leaving the hive have more pollen in their hair than bees that are inside the hive. And even the bees that are on top of the hive, in the middle of the brood nest, have about the same amount, several thousands, but the hive-leaving bees have more. And this is not so surprisingly, because hive-leaving bees collect outside, and they give up their nectar and leave the hive immediately to return, to go back to the tasks. Okay, so we know that our honeybee colony has collected material outside. Can be heavy metals, can be plant pathogens, can be all kinds of things. But how do you collect material from a colony? You can do it sacrificially, so that means you take bees and you kill them for analysis, or you can do it non-sacrificially. And that's the new method that I worked on for some years. And the principle of this method is that we have bees that enter the hive and leave the hive, and we have a method that they do it via different tubes. And the bees that enter the hive go through the, I'll show you, this tube. This is the hive entering tube, and inside this tube I've made some sticky material, and part of the particles that are on the bee will remain on this sticky material. You can take out this tube, analyze it, and you see what the bees have been foraging on. This tube that are extended from the bee hive are used for the bees for hive leaving. So this is more on the what we call the beehold device. Again, they have the hive entering bees and the hive leaving bees. And actually it is a movie, but it doesn't play because of the capacity of the computer. No point. You can imagine that the bees that enter the hive go through this tube, walk over sticky material, and leave part of it on this material. How many bees can you sample? Of course, we have about 30,000 bees in our sample, and we know part of them are foragers, so we can take them all. And then we don't have the colony anymore as a biosampler, so we don't want to do this. And we have made some calculations how many bees you can sample. And from a big colony, about 10,000 bees. You can sample every 2-3 weeks about 150 bees, and a big colony about 375 bees every 2 weeks. By applying the non-sacrificial sampling, we don't take bees. So that means that the number of bees is unlimited. We can use. We don't want to have, and we don't want to do this by sampling just randomly. There's a kind of structure, and it depends on what you want to know. That we call the target method. It can be floral or non-floral. Floral means you have pollen. Non-floral can be heavy metals, dust, whatever. It depends also, and it's important, where do I have to sample? Where do I put my colonies? Is this on a certain site? Is this for the atmospheric deposition? Also, where I have placed my honeybee colonies, is it randomly in the field? Do I sample individual colonies, or do I pour all these samples in an apiary sample? I can show you some examples of it. Where do I sample? Inside the hive, on the flight entrance, and do I apply sacrificial or non-sacrificial sampling? Meaning, do I take out the bees for analysis, or do I use this other method of these tubes with a sticky material? Starting with pollen, okay, you can use your pollen trap, and a lot of you all do, and we know that the efficiency of the pollen trap is about 10 to 50% depending on the pollen. You can have also bee bread, and we have the beehive tube if you want to have this pollen-like stuff. If you want to have an idea what bees have collected in the nectar, we have to take out the proventicus, so the honey stomach, and this is over, let's see, it's over here, this part, meaning that when you want to have this, you take out the bees that enter the hive and freeze them immediately, and afterwards take out the honey stomach, do for analysis. A lot of work, I don't go into for this presentation. Back to the bee bread. Why don't we use bee bread? Bee bread is pollen collected by the bees. It gives you a kind of indication that the bees have forage on. And okay, you can use it, but as you see on this picture here, it consists of all kinds of layers. And the residence time of bee bread in a colony is about 3 weeks. Can be more, can be less, but this is kind of average. So that means after 3 weeks, you don't find anything back what the bees have collected. When I go to non-target, non-floral plants, we can think about heavy metals and plant pathogens. I can show you some examples of this, but also pesticides can be collected by the bees, showing that bees have been exposed to pesticides. And I did a study on HCH in the Biavlerforenings region some years ago. Going back where you want to collect your stuff, it depends on the landscape. And here I have a small picture of what we did in the Netherlands, and it's a picture of one of the IJsselmeer polders. And you see the landscape is quite diverse. So, as I showed you before, bees are focusing on floral plants, on patches that have good yield. So they divide themselves over this field. At the right side, I show you these bars. This was from a study I did in Austria, and I had my bees in an orchard with flowering apples, and afterwards I checked what's the percentage of rosacea pollen, the pollen collected in the fruit trees. And as you can see, it's a bit different between the locations. I had 3 locations, but it's about 50%. That means that the other 50% of the foraging bees, at least the pollen foragers, forage somewhere else and not in this particular orchard. When I want to see if in a certain region there is a atmospheric deposition of whatever pollutants coming from traffic or from factories, I can place my bees anywhere. But there are several studies that have shown that nearby woods or nearby hedgerows, there is more deposition of heavy metals. And that's not, but that's strange, because whereas the wood, the wind is slowing down, so the heavy metals, the small particles that go along with the wind go down there. And also in the wood, it's colder than outside the wood, so the wind is going down. And in pine woods, you also have honeydew, sticky material that also collect these heavy metals. So when you really want to have an overview and some information about pollution in your area, and you want to use honeybees for it, sample them in the vicinity of woods or hedgerows, because there you have the most pollution. As I said, some earlier slides, you can use the information of one colony, but also you can use the information of the complete apiary. And how many bees do you have to sample then? And I did it based on the information that I had on metals of copper, lead, and cadmium in a study in 2006. We need about 5 colonies to have a kind of overview what can be detected in a certain region within the foraging area of the bee. Going back to this non-sacrificial sampling, as we use it for this bio-sampling, I already said before, it's only for hive-entering bees. It's a limited sample size. Every bee can go through. There's no impact on the bee's performance. They don't behave differently. And part of it sticks within this tube. And how many bees are more or less entering this tube? Well, we did a lot of calculations, and as a rule of the thumb, you can say that when you have more or less an indication how many bees are in your colony, and I showed you one of the first slides, that number is also the number of bees that pass this tube. So a colony of 10,000 bees, then about 10,000 bees will enter the hive per day. Then, a very critical question, why should I sample honeybee colonies and analyze them for heavy metals? Well, heavy metals are important. They are toxic to us, to humans, but also they can be toxic to bees. And I must admit, there are no recordings of heavy metals that have really caused intoxication of bees in practice. But there have been done studies that high concentrations have an impact on the foraging ability and on the navigation, because it affects the neural system of the bees. Where do these heavy metals come from? Well, they come from pollen, they come from nectar, because every pollen has a certain amount of metals, minerals that have a biological function. Bees need them. And they come from what we call anthropogenic sources, so man-made sources. And then, taking the most obvious example, our vehicles, our cars. Iron, bismuth, you see a lot of them, are related to the traffic. And for instance, this tire brake sink is especially related to the car and to the brakes of the brakes of the tires. On the other hand, we also know that when you do analysis of the soil, when you have a lot of certain metal in the soil, you also find it back inside the flowers and also inside the bees. Then you come to the interpretation, because every bee that you analyze has a certain amount of heavy metals, part of which is normal, but when is it not normal anymore? And then we can use two ways. You can use when there's a significant exceeding of the concentration. You can see here, this is what we call normal, but it can be much more. Or you can use another method using part 2. This is not important in this, but it shows you that having data of a honeybee and of a honeybee colony, just have to have some interpretation before you can say this is really a pollutant or this is normal. There are a lot of differences in variation, and this is an overview of the data that I collected in the Netherlands and Maastricht in the south of the Netherlands. In the south of the Netherlands, in the middle of the Netherlands, and near Rotterdam. And you see, and I did it in red, there are some significant differences. For instance, I can show you here, vanadium, it's rather low in Maastricht and rather low in Buchenham, in the south, and a bit up north, but in Rotterdam, where the harbor is, where a lot of industry is, there's really a lot of vanadium compared to the other stuff. And you also can see this for strontium. Also here a high number, and here in Maastricht. And this is a rural site, you find a lot of. So you really do find significant differences in heavy metals in bees. These heavy metals come on the flowers via the air. So the next question was, can I really see what I find in the bees? Is this really related and correlated to what the air sampling shows you? And that depends on the concentration and on the differences in concentration. As you can see here, for cadmium and for lead, we didn't see any differences. But for vanadium, where we have big difference in concentration, you can see there's a certain relationship between what's in the air and what we can see in the flowers and later on in the bees, showing the way, the root of the heavy metals and how we can use the bees to show this. Another example is the survey study we did in the Netherlands about 9 years ago, and we used 150 apiaries, and you can see here the map of the Netherlands and the red dots that are the apiaries, to see are the differences between all the regions in the Netherlands when we look at the heavy metals that you can detect in bees. And here you see you really have the differences, and this is what when we look at the land use, and you see that in the woods, and I showed you before, in woody area you have much more pollution that can be collected by the bees than in agriculture areas or urban areas or with land use. This is because what I told you, the microclimate in the wooded area is different and collects more of the air pollution. We also see, this is an interesting slide, there are big differences in this small country like the Netherlands, and probably be more or less the same here in Denmark. When we look at selenium, we see this is postal code 1, and this go up to 9, and I'll show you on here's 1, and here's 9. You see, looking at selenium here in postal code 1, and this is here in the north of the Netherlands, you can see a lot of selenium, and it's about 0 here, but that means there's the median. So you're on top of it. In the middle of the Netherlands, there's a very limited amount of selenium you see, but in the north, and then we are checking here in Groningen, Friesland, and Drenthe, the northern provinces, we do have a significant amount of selenium, and we don't know why it's there. I can't explain it, but you see a real difference. So in the northern part, there's selenium, in the middle and the south part, you don't find hardly anything. And the same goes for aluminium. You see not that much in the northern part, at least north, in Holland on the western side. And it may have to do with the coast and the dominant wind from the coast, but here in the northern part and in the eastern part, so these numbers of postal codes, we have significant more aluminium. So really, the bees can tell you about the burden of heavy metals in the environment. Another subject, Avinia pyrrhifolia. Avinia pyrrhifolia is a bacterium that causes an infection in strawberry in glasshouses. bees are applied for pollination in the glass houses. So they collect pollen, they collect nectar, if it's there. And doing this, they also collect plant pathogens. And we could show in this this graph that when there were some symptoms in the crop that there might be an infection. We could show it on the petals that have a little color. We already found them in the bees, a bit later on in the beehive tube as well, showing, and there have been a lot of studies also on fire blight in orchards, that honeybees collect bacteria before the farmer can see there is an infection. This also means that the bees can also spread this disease before the farmer can see it. But the combination pollination, bioindication, biosampling of plant pathogens is a very promising one, because the bees are there for their pollution, and you can use them to see and have information about the health status of the plants bees are foraging on. Coming to the last slide and about pollen. Of course, we are very curious where bees are flying on. In the beginning, I showed you that due to the bee dances and prophylaxis, bees are really focusing on plants that give a lot of pollen, give a lot of nectar. And in the CSI study, the color CSI study, we know that there are more or less 4 to 5 dominant plant species that bees collect pollen on. And this is an example of the beehive tubes we have in Germany. In this study, you see that, for instance, when we look at the dark ones, this is Tilia, Linde, and I suppose in Danish it's also Linde. You see it in the second half of June and continue till July, and end of July there is no more of this stuff. But every time you see here about 4 to 5 dominant plant pollen. And also you have other causes, for instance, this purple one, Plantaginacea, is very low here and goes up there. So you get quite a good overview about the pollen collection and about the diversity of the pollen, even without collecting pollen. This is done with the beehive tube. You just put on this tube, leave it for, let's say, a week, take it out, process it. It's not that hard to do, and you have a perfect image of where the bees have collected the pollen on. On the back, and sorry, it's in Dutch, but it's not that different from Danish as we write it. Bees really prefer to collect pollen from flowers, from hedge roses. Of course, it's not that strange, because per square meter you have many more flowers in a tree than on the soil. And they really like it. And also, trees and hedge roses are, as scrums, are very constant in their nectar and pollen, because they have deep roots and they are less dependent on the water and on the rain. And you see in June, many bees collect on flowers, but in the course of the season, towards the end of August, there are no flowers in the trees anymore, that they completely depend on annuals. And that makes them more or less vulnerable, and really it shows you how important it is that to have flowering trees and hedge roses along the year. But again, this gives you an indication where can the bees fly. So this is another aspect of the biosampling of the honeybee colony, not only on plant pathogens, on heavy metals, but also where can the bees forage on, and how are their conditions. This is the end of this presentation, and there's much more to say about the subject and how you can use those bees. I just try to give you an example how this complete different application of honeybee colony also can work for you. I thank you for your attendance.
Thank you very much, Sjef. Unfortunately, we have to say that there were some sound problems, but we got quite a lot of questions anyway.
Okay.
So I'm very happy. I just have to push the right button so that we can. Where's that button? Yeah, it's like here. So you can see out in the chat that there were lots of questions. I just have to ask everybody, can you hear me talking? Yeah, they can hear me. So the question.
But they don't see you.
No, they don't see me. Oh yeah, we can now. They don't need to see me. So we make the questions now.
Yeah, please do.
It is really a big concern between all the listener. How is it to have bees in the town, and what happens with the honey? Should we be concerned?
I think it's a real concern because we know that the pollution in town, and especially when we have this traffic and the low wind in the towns, I suppose, but I don't have field data on it of my own studies, but I have seen other studies that the pollution of the honey and the pollen in town is higher than outside.
So, but is it on a level where there should be kind of beekeepers concerned?
No, not yet, because the levels that we really should be concerned are that high that at least I've never seen any data on it.
Okay.
So it is higher, but same goes for when you have your bees in the natural area, in the forest. You think, well, this is really good place to be there. But living in countries like Netherlands or Denmark, the pollution can go for kilometers due to the high stacks and the position kilometers away.
So do you have a kind of take-home message I mean, in the Danish Beekeeper Association, we have a big pollen collecting project. Yeah. Now we want to start collecting pollen and selling it as a food supplement.
Yeah.
Is there any kind of take-home message? Is that a dead-end kind of project, or would you say it's possible? Should we keep away from rape fields? Should we keep away from certain areas?
In general, I should say keep away from intensive agriculture areas because of possible pesticide use, although we hope they don't apply pesticides when the rape fields are flowering. But again, in these natural areas where you have a lot of pollen, there can be pollution in it. So the take-home message of this is continue, go on, but be aware of the risks that you take. And if you have any doubt, let some samples simply examine, analyze for it. That you have any indication that pollen collected in Jutland or in Zeeland or whatever have the same amount of heavy metals. And there is, of course, a certain natural amount of heavy metals in it.
From natural
from natural, yeah.
Yeah, okay. So another one is asking, are you the only one who has been working with that? Can you compare with other countries using kind of bees as pollution collectors? Or
there are not that many countries that work with bees as bioindicator, but in Italy there's a lot done, and nowadays it starts also again in Eastern Europe. There are a lot of studies done, and that's more about it. It's Italy and Eastern Europe and the Netherlands that have been working on this. And it's not that obvious because most studies are done on other subjects, and there's a lot of infrastructure for normal that you can see pollution and environmental pollution. So it's limited, but there are a lot of studies done over the last decades. And I must say there's a very famous study done in Finland already, maybe 20 years ago. So it's not that big subject, but people are working on it and it's giving very interesting results.
So what do you think is I mean, some people that they're earning money on collecting honey, others are selling, hiring bees out for pollination. Will the future for beekeepers be that they hire out bees for this pollution?
Yeah, I don't think they should have hired out bees. My ideal picture is that when there are some apiaries, we call them monitoring apiaries, are provided with, for instance, this bee tube, so this beehive tube, you don't have to sacrifice bees, are just provided with these tubes and checked regularly to see if there is any pollution. You don't have to do anything for it because the apiaries are already there, the beekeepers, the honeybee colonies are there, so you can simply use them. It's the only part you have to make a kind of infrastructure to collect it and to have it analyzed. But it would be give a great chance to have an overview of Denmark about pollution of heavy metals, plant pathogens, and also about pollen diversity.
I already have to, you just gave me an idea because we have this monitoring apiaries in Denmark. We have 50 of them, actually we're going up to 60. So I just need to get some money from somewhere and then we could use those kind of. How much is the price for a sample for all the heavy metals? What is the price? Just, I mean, approximately.
It depends on the laboratory and how, what the limit of detection is.
Yeah.
But I think for €100, you have a lot of them.
Okay. So already some of the spectators here now, they volunteered for being in the project like that. So we just need, what was it, €100 per sample? Well, we have to do it several times during the year.
Yeah, but when you have a lot of samples, you can not pull them, but you can offer them in the same time.
Yeah.
And you can make a price in the commercial laboratories, I suppose.
But it would be very exciting. Could you kind of help us if we, I mean, we have to get the money and then kind of organizing that would be very nice.
I would be glad to help you out and see how we can use the Danish monitoring colonies for this purpose, of course.
Maybe this is a question again. I mean, you in actually the Danish Beekeeper Association, we try to promote the local towns to kind of plant a lot of flowers and very often we have this very big roads and in the middle there is some grass. Yeah. Now we planted there. Is that a concern? You kind of already said no, but
it's not a real concern. Of course, the plants that are in the vicinity of the road have more heavy metals. We know it, but not that high levels that's dangerous for the bees. But there's also a big benefit. You have to also see the other side. Having sufficient flowers for the bees also help them to get more vital life. And no, don't make that big concerns about it. And I don't want to end up with this presentation by scaring the beekeepers. Now, I did these studies and I really want to promote the use of honeybee colonies as a biosampler, just as a tool, additional tool to the environmental infrastructure. And especially, and that's why I worked on it, there are a lot of countries, and don't talk about Denmark or the Netherlands, but in Africa and Asia where there's no environmental structure, there are honeybee colonies and they can be applied for this.
Okay. So of course we get this because we had this talk yesterday by Preben about organic honey. So do you have an opinion about that? Could we, if you have this, if you are a certified organic beekeepers, can you be sure that you don't have heavy metals in your honey? Is that for sure or
no, because the areas where you collect organic honey, is about the application of pesticides and land use, and not what's coming down from above. Okay. So no, I can't say that. It's not the definition.
Okay. I have to ask to everybody now, did I remember I wrote down the questions that came during the talk. Have I forgotten any questions, and are there any additional questions? Then you have the possibility to do it. Ask now. And I can see somebody is writing. Yeah. One of them is writing, that was great. There was the other guy asking about the honey. I don't remember the question, but I think you already answered it. Is there any concern for heavy metals in the honey?
There is a big difference. That means that very light honey has on average less heavy metals, and we call it minerals, than dark honey. Okay. Dark honey, and that's already known for a long time, especially honey collected from honeydew, has significant more minerals than light honey.
Wow.
This is because the origin is different. Yeah. The origin is different because it's produced by aphids, and it's taken from the cassette screen. It's different. So you have different kind of metals. Additionally, it's sticky material on the outside. So also what's coming down also sticks to it.
At least it makes me happy because I mainly have rape honey, and that's a very light honey.
Yeah.
And I'm always very jealous on the heather honey beekeepers or other types of beekeepers. There's one asking, have you been working on what you call it, the farming spraying or the pesticides that the farmers are using? Do you have any comments on that? You know, agriculture spraying for pests and is there
Related to this,
yeah.
I've been working on it.
And I think in general, and this guy is asking in general, and especially from rape fields.
Yeah. Well, I've been working it in the rape field, and I did see that when there's certain, this was in this case, fungicides are applied, you can see it in the bees and on the bees and in your beehive tube. You can see the point is that we don't count every bee that's entering the hive. It's impossible with the techniques that we have now, so you can't make a real relationship. But you can see there has been exposure, bees have collected it, and bees have collected something, you know there's been exposure. So it gives you again kind of indication that same as you can use in your monitoring activities.
Okay, there's still one. I think there's still one question coming up, or maybe it's not. Martin, did you regret your question? Otherwise, okay, this. Otherwise, I want to thank you a lot. It was a very interesting talk, and it's really I got again. My head is getting filled up with more questions inside, and people are saying thanks a lot. And what we need here in this kind of webinar is kind of getting reaction from people that are writing in now. It was great. So I will stop the recording and thank you a lot. And then I have to ask the participants a few questions because it turned out that we had some sound